Let's look at this example. Two cars are 276 miles apart and start at the same time to travel toward each other. They travel at rates differing by 5 miles per hour. If they meet after 6 hours, find the rate of each. So what we have is we have two cars, one at point A, the other one is at point B. They're traveling toward each other, right? The distance between them is 276 miles and they meet after 6 hours. So that means they both drove for 6 hours and that's when they met. So what we have is the following here. So I'm going to assume that car to the left is, let's say that's car 1, and then the other one would be the car 2. So let's say that car A travels at x miles per hour. So that means let x be equal to the rate of car 1, and then let x plus 5 be equal to the rate of car 2, right? And then we can make a table here. We know the rate of car 1 is x. The rate of car 2 is x plus 5. And since they both drove for 6 hours, the time would be 6 for both cases. Now, to find the distance for car 1, well, the distance that it covered, in this case, since we don't know what the rate is, distance is equal to the rate times time, so I'm going to say it's x times 6, which in this case is 6x. And for car 2, we can say the same thing. Distance equals rate times time, so 6 times the x plus 5. Now, we also know that the distance that car A travels plus the distance that car B travels is going to be equal to that total distance that we were given, which is 276, right? The distance from car A plus the distance from car 2 should equal to the total distance, which is 276. So we can distribute the 6 and solve for x here. So let's distribute the 6 to get the following equation. Combine the like terms, 6x and 6x makes 12x. Subtract 30 on both ends. And we can divide by 12 to isolate the variable x. So that means x equals 20.5. And we know that x represents the rate of car 1. So we know that car 1 is traveling at 20.5 miles per hour. And remember, car 2 travels at 5 miles faster. So that's going to be 25.5 miles per hour.